Hi, everybody. We're going to get started in just a couple minutes. I see everyone is getting logged into the webinar here. So just a minute or two more and we will get started. Thank you. Okay, well, I think we're going to go ahead and get started. Good afternoon, everyone, and thank you for joining us. My name is Chris Vonamy. I am the Deputy Director for the DuPage County Stormwater Management Department, and we are here for a water quality outreach webinar that will cover a green infrastructure plant selection and design tool. The tool is an easy to use Excel spreadsheet that assists with plant selection for green infrastructure applications. We will learn about the functions of the tool, including how it allows users to narrow down plants by site conditions, plant function, costs, and maintenance considerations. This is a free webinar, and one PDH, one professional development hour, will be available. We have several of these workshops throughout the year. We find that these workshops are a great way to connect like-minded individuals and organizations who are concerned with the water quality in our area's lakes, rivers, and streams. These workshops are part of our public outreach and education programs, and they help us meet requirements outlined in our permit with the Environmental Protection Agency. This webinar is being recorded, so if you know of others that can't be with us today who might benefit from this information, we will provide a link to the recorded presentation shortly following the webinar. All right, just a couple quick thank yous before we begin. Thank you to Mary Mitros. She is the Stormwater Communications Supervisor, and she is behind the scenes running our show today. Thanks to the Conservation Foundation. They are our partners for all of these workshops and webinars, specifically Jan Rail. She is the DuPage County Program Director for the foundation, and she helped line up our speaker for this afternoon. And speaking of our speaker, thank you to Jason Cooper from Environmental Consulting and Technology Incorporated. Thanks for being here, Jason. And once again, I'd like to thank our audience for joining us this afternoon. Just a couple other quick comments here. I wish I had known that this plant selection tool was available last year when I planted several areas in my yard with native plants. I'm sure our wetland staff would have appreciated me having this tool also. They could have avoided several conversations with me where I would ask about a plant and they would have to say, no, Chris, I don't recommend that plant. That is purple loosestrife, and that's a noxious weed. Or they'd say, yes, Chris, that is the perfect plant if you lived in the Congo in Africa, but that's not really native to Illinois. I could have saved them a lot of time and frustration. And although I have not seen Jason's presentation yet, I would like to make a couple of suggestions. I realize that this particular tool is in the form of a spreadsheet, but I hope that phase 2 of this tool can be developed with an adaptation or a retrofit that will incorporate features such as motion sensors, night vision, and laser guided missiles to eradicate all of the rabbits within a 10 square mile radius of my backyard. These rabbits believe that the native plants that I planted are merely no more than a salad bar. And that leads me to my favorite rabbit joke. What does a flying rabbit have on its back? What does a flying rabbit have on its back? That obviously is an eagle. because it's dinner time and there would be one less rabbit to eat my plants. All right. I am excited to learn about this plant selection tool, but before I do, I want to remind everyone that you are muted. If you do have comments or questions during the presentation, please type those directly into the chat box, and we will relay those on to Jason at the end of his presentation. And one final note, remember the audience members are responsible for their own video cameras, so whether you want those on or off is completely up to you. Okay, so let me introduce our speaker, Jason Cooper. Jason is a senior landscape architect for Environmental Consulting and Technology Incorporated. He is a PLA, a professional landscape architect, and a LEED accredited professional. Jason's work as a landscape architect has expanded the integration of green infrastructure systems and restoration design principles around the Great Lakes region and beyond. His design portfolio is comprised of headquarters for Fortune 500 companies, more than 50 park and recreation facilities, numerous downtown streetscapes, and many natural area restoration projects. Jason is versed in a broad range of green technologies, with significant practice in applications such as bioretention, rainwater harvesting systems, permeable paving, LED lighting, and clean energy delivery systems. Jason is a recognized authority on the design of green and complete streets, green roofs, green infrastructure, and green schoolyards, and is a frequent presenter at conferences and workshops such as this. So with that, Jason, thank you for being here. And Mary, let's turn things over to him so he can begin his presentation.
Thank you so much, Chris. I really appreciate that introduction, and I'm excited to be here today and speaking to everybody here about plant selection for green infrastructure. It is a fascinating topic to me, at least, so I really do enjoy this presentation. Here we go. You can now see the presentation.
Yep.
A lot of my work has been in and around green infrastructure in a variety of different settings. This is a office campus up in Glendale, Wisconsin. And that's a constructed wetland over to the right. Actually, we won't be talking too much about constructed wetlands today, but we will be talking about other green infrastructure practices and a methodology for approaching the subject of plant selection for those different practices. Green infrastructure has multiple benefits, but its biggest and the reason primarily for its use is its ability to manage rainwater runoff. And it often replaces traditional stormwater management features and traditional large end of pipe detention facilities. When I'm involved with green infrastructure design, I often work with civil engineers and ecologists. So it's definitely a team effort, and these applications require a multidisciplinary approach. And often a lot of time is spent on the civil side of things with stormwater sizing, calculations, flow rates, storage volumes, and the like. And all of those plans and details are shared with permitting agencies and are regulated. But what often ends up causing failure with these systems is something we may not always spend a lot of time on, is plant selection. So we'll spend the next 40 minutes talking about that and how to approach it more successfully. This project, the talk today is introducing a project that we participated in for the Milwaukee Metropolitan Sewerage District, or MMSD. Like other agencies around the Midwest, they have been promoting the use of green infrastructure, but they've also seen some setbacks in projects in the area that they wanted to avoid. And so they reached out to ECT to ask for our help in developing a tool to guide the selection of plant material. So today's talk, I'm gonna try and break it down into these 5 categories. We're first gonna talk briefly about the underlying stormwater problems that our green infrastructure and the vegetation within that green infrastructure is attempting to address. Those of you who are civils or are on the engineering side of things will be very familiar with these. If you're not, if you're a homeowner, these might be new subjects to you. We'll then talk about why vegetation. What does vegetation do in these practices? And then specifically what those practices are. We're going to be talking about rain gardens, bioretention facilities, naturalization practices, and also green roofs. So the role of vegetation in each of those 4 areas. I'll then talk briefly about habitat and cultural considerations for those plants. And then lastly, we'll get to the plant selection tool, which, as Chris mentioned, is an Excel spreadsheet, and Excel spreadsheets don't often lend themselves to pretty pictures in webinars. So we won't have too much of the actual Excel spreadsheet to present, but I want you to think about the spreadsheet as a step in a successful plant selection methodology, an approach, if you will. So I want to start off, and I start this talk off with this beautiful graphic that a colleague of mine presented. So selfishly, I like to share it because it's such a nice graphic, but it is also presenting something really fundamental and important to why we're managing stormwater in our area. The issues that we're facing are a direct result of the change in the hydrologic patterns in our area. Historically, rainfall did not run off the surface of the land as it does today. Rather, it infiltrated into the soil. And then it moved oftentimes laterally through the soil before it emerged days, months, sometimes years later into a wetland system. And that's very different than what's happening today. When water moves that slowly through the soil, for one, the temperature changes. Generally, it cools down and is a consistent temperature when it finally emerges. It's also naturally filtered of sediments, nutrients, metals, and its pH is altered. So it's chemically very different than the water that entered it when it finally does get released into our wetlands. And so the idea that existing or historic wetlands are a good place to manage stormwater is a really false one that I'd like to just put out there, because true wetland systems were the recipients of extremely clean, consistently flowing water. That's not what we're managing today. The current hydrologic patterns are changed through the addition of a lot of impervious surface. So all our building roofs, parking lots, roadways, those shed water at a much faster rate. They speed up the velocity. They also contribute a lot of pollutants such as suspended solids. They run across landscaped areas, which add nutrients, fertilizers from agricultural fields. And they prevent a lot of the infiltration and recharge that we would have historically seen. They also end up increasing the volume and rate of water reaching our aquatic systems, our wetlands, our rivers, our streams, resulting in flashy conditions and additional erosion in the stream corridors and poor water quality. So the main issues we're attempting to deal with all of our stormwater facilities, but particularly the green infrastructure practices, are summarized on this slide. So CSOs in the upper left, which stands for combined sewer overflow. Milwaukee, like Chicago, is largely served by a combined sewer system, meaning that both sanitary and stormwater flow in the same pipes. Now, I'll tell you that's sediment being discharged into Lake Michigan in the upper left corner. It's just sediment. It's not raw sewage, but the picture is indicative of what actually does happen in extreme rain events in cities that are served by combined sewers. We get combined sewer overflows, which are the reason for a lot of beach closures and other health issues. Soil conservation, like I mentioned on the previous slide, we lose a lot of existing topsoil along our river and creeks, also on our agricultural lands. Those of us in urban areas, I'm sure, have experienced flooding, both localized and also if you live along the Missouri River or the Mississippi River, a lot of large-scale flooding issues. And then the loss of habitat for our aquatic plants and animals. So why vegetated green infrastructure? The practices I mentioned before, which are bioretention, rain garden, green roofs, and naturalized landscapes, are all green infrastructure. I would also add permeable pavement systems as green infrastructure. And then also constructed wetlands, I would consider green infrastructure. I won't be talking about those last two. And permeable pavement obviously doesn't have vegetation. So what benefits do we get with a vegetated green infrastructure system that we don't get with non-vegetated? Well, for one, it provides habitat. Here's this is a restored creek corridor, but those are turkey up at that same Glendale office park I showed on the first slide. So we add habitat both for native plants and native animals. Vegetated green infrastructure also mimics the full suite of hydrologic processes. So infiltration, evapotranspiration. We're also improving soil health. And it's definitely an aesthetic enhancement when you consider just the loss of greenery in our denser urban areas. The presence of vegetated green infrastructure has an obvious benefit. When we talk about vegetation, there's a variety of different types of vegetation that can be used in green infrastructure. This is a beautiful drawing I'm sure many of you have seen before, prepared by our friend Heidi Natura of Living Habitats. She did this a number of years back when we were both affiliated with Conservation Research Institute. And it demonstrates the deep structure of root systems of herbaceous native prairie plants. A lot of herbaceous plants, not just our native prairie plants, have these densely knitted root systems. And it's the reason why with rain gardens and bioretention facilities, we often turn to herbaceous plants that have soft stems and above ground features rather than woody plants, because the herbaceous material does a better job of building that soil environment, encouraging infiltration, stabilizing against surface erosion, better than, say, widely spaced woody shrubs or even wider spaced woody trees. So when we're talking about plants in green infrastructure, herbaceous plants and often native herbaceous plants are the ones we're most interested in for those reasons. Here are the pictures of the practices that MMSD was interested in getting our guidance on. They've identified 4 that they target for supporting within their district. Rain gardens, there's a picture of a rain garden in the upper left, picture of green roof in the upper right, naturalized plantings in the lower left, and a bioretention facility in the lower right. These are all ECT projects that our firm has been involved in. And I'm going to take a minute to talk about what's specific to each of them and how they differ. The biggest one to talk about is what's the difference between a rain garden and a bioretention facility. And I wish it was clear, and I've been designing these facilities for the last 20 years, and it's still not that clear to me. to some degree, a rain garden is a marketing term. We're often encouraged to use the term rain garden when we're describing facilities for a lay public, that a bioretention facility might be too technical. What is bioretention? Whereas a rain garden, everybody can kind of understand. It receives rainfall and it's a garden. But for MMSD, they have an actually a technical differentiation that I've begun to adopt that I like. For the MMSD, they've defined a rain garden as a facility, a basin, could also be a swale or a channel, but it's a depression in the ground that is not under drain and is generally built with existing native soils in place. So that's an important distinction from the next one we're going to talk about. If you're just digging a hole, whether it's a circular shape or a channel, and you're not bringing in special soils or draining it with a gravel layer below those soils, it's probably going to be a wetter environment than one that is under drain. But the rain garden does have a limit in how much water it will receive. The basin will be designed to capture a certain depth of water, and there'll be a control to allow that water to overflow and leave the system. That control could be a weir or a perimeter edge where the water then overflows, or it could be literally a structure like a manhole with a grate that the water enters into. And sometimes it's built with a restrictor device to hold the water back from that ultimate outlet. This is a picture of a rain garden. You can see it's rained recently and the water is collecting at the surface. And this facility is designed to have water pond at the surface, but generally for a limited time period. And most regulations require that that be drained within 48 hours or 2 days. And here's a bioretention system. So a bioretention system would look very similar at the surface, but based on MMSD's definition, it is a completely new construction, which starts with a gravel layer that has a perforated pipe to relieve the system of water. And above that is a soil layer, and the soil layer above that is an engineered mix generally. So not native topsoil, but a combination either of topsoil or some other organic, high organic content soil plus sand. And the plus sand is really important because this is a highly permeable environment where water moves through really quickly. Shape-wise, there's no reason it couldn't be a round or channel shape. The primary distinction for MMSD at least, and for me as I go forward in my practice, is that this one is under drained. Both facilities, rain gardens and bioretentions, permit infiltration, but that infiltration and the rate of that water going into the ground beneath the system is going to be limited by the square footage of the system and the infiltration rate of the underlying soils. So those are two things as designers we look at before we design the system, so we can anticipate that. In this cross section, the only water that really is possible to infiltrate is that retention volume below the system. In terms of plant health and plant selection, the important distinction here is one of these systems has a very well-drained, relatively dry soil over a relatively dry gravel layer, and the other one, the rain garden, is just native topsoil, and that can be a big difference when it comes to selecting your plants. Another system that MMSD encourages are green roofs, and green roofs are fantastic. They really reduce the runoff rates off of building roofs. They have other benefits such as reductions of solar heat gain, which can help alleviate the urban heat island effect that we get in our urban areas. They're generally not used for large storage of rainwater. They're relatively thin in profile. This would be the typical construction of a green roof. You can kind of see that it's very similar to that bioretention facility. It's just on a smaller scale, but it's basically the same system with different materials performing the function. So you see a gravel layer, there's a separation fabric, and then above it is a growing media or soil. And again, this would be a highly permeable soil media, at least for most green roofs. The last application that MMSD wanted our help with plant selection for were naturalized landscapes. Now, this is a constructed wetland in Troy, Michigan for the Kresge Foundation. I share the picture not for the constructed wetland part of it, but for the upland naturalized vegetation. So this is a native wet prairie, native upland prairie around the constructed wetland. MMSD is encouraging landowners and developers in their district to replace turf grass and other surfaces such as paved surfaces with naturalized plantings. The benefits there, if you remember the picture that Heidi had drawn with all those deep-rooted native prairie plants, really encourages infiltration, reduces flow rates across the surface, and improves soil health and has other benefits. So even without any detention storage, simply having native prairie plants is a benefit. The reason we're given the talk, though, is because even though the presence of vegetated green infrastructure is beneficial to the stormwater leaving the facility and is beneficial to the overall site hydrology. These practices restore natural hydrology. The fact that the plants are in the green infrastructure is not necessarily beneficial to the plant. We're using plants to some degree as mechanical filters, and it's not what they've evolved to be. And I'm throwing this slide up to kind of present the crux of the problem, which is surmised by Dr. Jerry Wilhelm, who I used to work with. He had a quote, which is the law, the botanical law, he'd like to say, and it was immutable. It's plants always obey this law, which is that they grow in habitats to which they are adapted. And plants don't lie, they follow the law. And the converse of this law is true also, which is that if you change the habitat, the plants you put in there won't stay, and other plants that are more suited to that habitat will move in. So if you prescribe to this law and understand it, then you have to select plants which are suitable and perfectly adapted to the habitat you're creating. And the practices I just shared are not natural habitats. They differ from natural habitats in a lot of ways. And in order to pick the right plant material, you have to know how they differ. So that's what we're going to talk about next. These are not the only habitat considerations for green infrastructure. It's actually a version of this presentation I've given, which has like 8 more, but it took like 3 hours and nobody was interested in going along and listening to all of it. So these are the ones that we are attempting to track with the plant selection tool. And so these are the ones we're going to talk about briefly. And they differ with the different types of green infrastructure practices. So their flood duration, that's the period of time water is sitting on the surface of the soil. Soil moisture, that's how much moisture that soil will retain in between rain events, how much of that moisture is actually available to the plants. pH, when we're importing and building new soils, we sometimes alter the pH in ways that we weren't planning to. Or if we surround a planting with with certain other materials will change the pH. Sun exposure is probably the easiest one for us to predict, but is obviously very critical. And then the last one is one of the hardest habitat issues to deal with, which is the exposure to salt, primarily from de-icing agents in the winter. So allow me to go through these each quickly and share why they affect the health and the selection of plants in the system. So flood duration, plants don't actually drown if they're inundated with water for too long. They asphyxiate. There's gases that build up along the roots that can't leave when there's too much moisture in the soil. So everybody knows that green plants photosynthesize, and that's the practice of using light energy and carbon dioxide to produce glucose, sugar, and then they release oxygen. They only do that in the green parts of the plant. They don't photosynthesize in the roots, but they respire everywhere in all the living tissue of the plant. So they respire, and the respiration, which is the opposite process of photosynthesizing, respiring releases carbon dioxide, water, and heat. And they'll respire through their roots to differing degrees. And when water is built up in the soil, you'll get noxious compounds and gases building up around the roots, which will damage and eventually kill the plant. So it's impeded respiration that damages the plants if they're inundated with water for too long. Wetland plants obviously have the ability to endure that and tolerate that level of flood duration, but knowing how long the water is going to be in the system is important. Next critical piece is the available moisture in the soil. This is an agricultural chart, might be familiar to some of you if you've taken any soil classes. I'm not a soil scientist, but I'll attempt to tell you what you're looking at, which is it's a scale of differing soil types from sand on the left to clay on the far right. And it's demonstrating that different soils have different abilities to hold and make available water in that soil in between rain events. And so the bottom part of that, the wilting point, is the minimum amount of water that is present in the soil that is needed to keep a plant from wilting past the point of recovery. The line on the top is field capacity. That's after the soil has been fully drained from a rain event, how much water is generally left in that soil. And the space in between it for the different soils is the water in the soil that's available for the plants to use. And based on that, you can kind of see the best, generally the best soil for most plants is like a silty loam. And that's why most nursery soil, manufactured soils, potting soil that you get tends to replicate this type of soil. The challenge we have is like with that engineered soil I was showing for bioretention, the specifications I write often include 75 to 80% sand, which is really more like a sandy loam. And so we are sometimes designing systems that have a less than optimal soil moisture potential. Another issue, I won't go into too much detail about this, but is temperature in areas where we're putting bioretention facilities surrounded by a parking lot or buildings or curbs. Often that concrete or asphalt retains heat and emits it back into the soil, and soil temperature within parking lot areas can fluctuate dramatically. This is an interesting chart about the temperature in soil, and what happens as it elevates. And if you consider that some asphalt parking lot surfaces during really hot summer days can increase the air temperature immediately above the asphalt to like 140 degrees. Now the soil won't necessarily heat up to that, but you can anticipate what happens to the adjacent health of the soil. Sun exposure is a critical issue. Again, easier for us to track. There's a lot more information available to us as designers for where plants originally came from and what types of sun exposure they are accustomed to receiving. Salt is harder to predict in terms of each plant's specific tolerance to it. There are some plants that are known to be particularly salt tolerant. You know, cattails, one of the reasons we see them in a lot of roadside ditches is their tolerance for salt. There are some native plants like prairie dropseed that have some tolerance for salt exposure. But we are lacking enough data on all of the plants we have available to us for their tolerance to salt. So again, these are the natural habitat considerations that we have to track and understand how they differ in the different practices. But there are also cultural considerations. And this is where people come in. And people's expectations about how a landscape will look. In our state and in surrounding states, a lot of public agencies have pushed the use of native plant materials and native plant communities for green infrastructure practices. And rightly so, that's where they can be maintained. They're a great strategy for achieving multiple benefits in terms of habitat, infiltration. But they're not the only plants that will work. There's nothing about a plant's nativity that makes it more suitable for a bioretention facility, which is a wholly unnatural planting environment. So for us, we're not just purely using natives, in our practice at least. We try to match the owner's maintenance capabilities and desires with the right plants, because we'd much rather have a healthy, long-term ornamental planting that may use non-natives than a native planting that doesn't succeed and is filled with weeds. But we do recognize and walk our clients through the pros and cons of different planting approaches. So there's a bit of a spectrum that I'm representing on this slide, with a naturalized planting approach on the left that would likely include just natives of a specific native plant community. So like maybe a wet prairie, which is what we're looking at on the left. All the way over to the right, you can see some boxwood plants in there, but an ornamental approach which uses monocultures of natives and non-natives in more of a garden arrangement. It is definitely possible to use that planting style, an ornamental planting style, in a green infrastructure practice. The trade-offs are the ornamental style will have a medium level installation cost. It's not going to have a lot of habitat value. It can be easier to maintain, though, by conventional landscape maintenance contractors. On the other end of the spectrum, if you're seeding a native prairie plant community, it can have a much lower installation cost, and it also can have a much higher long-term habitat value and long-term lower maintenance costs, but there is generally an establishment period with more intense maintenance that can last 3 to 5 years. The Lurie Garden is shown in the middle. I'm sure you're all familiar with that at Millennium Park in downtown Chicago. That's kind of a halfway approach that many designers have taken, where we're using more diverse plantings, not monocultures, but 2 or 3 species in a grouping with the attempt to keep a ground cover over the site at all times. And that has potential too. So again, naturalized pros and cons. One of the cons is the aesthetic when used in small fragmented spaces. Native prairie plants are much coarser in appearance. And by that, I mean, they don't have the large flower displays or beautiful foliage that a lot of ornamental plants have been cultivated to have. So they look coarser, they look more raggedy. And some people don't like that. And when people don't like something and they're in charge of maintaining it or owning it, it often is not loved and maintained. So that's a consideration you got to have. Are you really committed to this native landscaping? Ornamental is easier to maintain because in a monoculture, a weed sticks out and you can stay on top of that weeding more easily than in a truly diverse native prairie planting. But an ornamental plant, a lot of these are sterile and they're not designed to replicate themselves. Whereas in a native naturalized planting, it's truly sustainable. It restores itself by reseeding. The last challenge we face, aside from cultural or habitat considerations when we choose plant material for green infrastructure, is just the sheer volume of plants that are possible. This is the latest edition, or the only edition, I think, of Flora of the Chicago region by Laura Rica and Dr. Jerry Wilhelm. A fantastic compendium of all the known naturalized plants in our Chicago region. And there's over 3,000 naturally occurring vascular plants in this tome. There's probably another 8,000 plants available not native through local nurseries. So, I mean, when I pull out my plant books, it's often daunting to say which are the best 5, right? And that's what MMSD kind of asked us to do when we first started. They said, you know, we have these practices and we want you to pick the 5 best plants for each of them, or something to that effect, thinking of it as like a template. But knowing the challenges of all the variety of habitat and cultural considerations and the just sheer volume of plants, we suggested a different approach. Now, this is not our spreadsheet. This is a tool that they had already developed for sizing their detention facilities. It's a green infrastructure sizing calculator, and it's an Excel spreadsheet. And we had seen this, and we had also developed Excel spreadsheets for plant lists that we use to draw from on our projects. And we thought, well, what if we could provide the district with a more intelligent tool than just a template of the 5 best plants? And we proposed, and I'm going to share with you in a second, an interactive Excel spreadsheet that allowed users to input the specific habitat conditions for their green infrastructure practice, choose a planting approach, and then that would narrow down a master list of plants to, say, 50 that they could choose from that would be appropriate for those conditions. The idea wasn't to replace a landscape architect. I really hope that it doesn't do that. It's definitely not that smart, but it, I hope, illuminates the correct approach, design approach to picking the right plants. And I hope it's also adaptable for other regions and situations. And I hope it's a good first step for maybe homeowners who want to do something, but go to a nursery and just have no idea there's 300 plants at the nursery, which ones are appropriate. They could use this tool to generate a list and take that list with them. This is a flow chart that nobody's going to be able to read. I don't expect you to, but it's a flow chart of the tool, the spreadsheet. it's a 3-step process. We thought it was important to keep it pretty simple. And so the first step is that you have to choose your design approach. Are you using just native plants in a naturalized setting? Or are you open to non-native plants in a more ornamental type planting approach? The second step asks you to choose your specific site conditions. You hit a button, and the third step spits out your customized plant list. There are, I think, over 500 plants that we included for the ornamental plant approach. So there's a master list underlying this tool that includes 500 plants, and there's about 100 native plants on the native side. And our requirements for including plants in this spreadsheet was they obviously had to be hardy in the Milwaukee area, so they're suitable for that zone. They're generally long-lived plants. We weren't including short-lived and reseeding type of plants, annual plants, if you will. But these are generally longer-lived perennials or woody plants. They're plants that we felt would be suitable for large-scale landscape applications, so we don't have tea roses and things of that nature that might be less suitable for large-scale landscapes. They definitely could not be a listed invasive species in the state of Wisconsin. They also, though, couldn't be threatened or endangered native species, and that's kind of important. It's something not everybody, I feel, always checks when we're working with native plants. I believe most, if not all, states require permits to handle and plant threatened or endangered species, and we don't want to encourage bringing in threatened or endangered species from a seed source outside of the immediate planting site. The plants on these lists also couldn't be overly aggressive, and they needed to be commercially available. This is the first page of that tool. It presents the idea of the two planting approaches that I shared on that spectrum. If you want an ornamental planting approach, which is represented by the parking lot on the left, this is actually Carroll Stream's Fountain View Recreation Center. It's a project we worked on. You would click that orange ornamental button. And on the right side, also a project of ours with a naturalized planting approach, also on a parking lot island. This page gives you more information too. It shares what I was speaking about before with the pros and cons of each approach, so you can get more informed and decide which one is right for you. And it also contains maintenance considerations for both, as well as costs for different installations. So we don't judge. You want an ornamental garden, choose the one on the left. Just know what the drawbacks are. Same thing with the naturalized one. The second step of the tool has a lot of buttons, and the under number 3 are the conditions I presented earlier. So sun exposure, soil moisture, salt exposure. This is where you would choose the specific conditions your practice is going to face. Some of it's pretty technical. We do give guidance in little pop-up buttons as to how to determine your soil moisture. So at-home tests that you can do. Same thing with soil pH. And then you can be more specific about the features at your site. We realize this might be too technical for a lay audience, especially maybe residents who didn't have a technical background. So we gave cheat buttons under number 2, where we say default selection for green infrastructure. You see the practices up there, bioswale at the top, then rain garden, extensive green roof, and semi-intensive green roof. If you choose one of those, you will get default conditions populated under number 3. So what they typically are. So for bioswale, soil moisture is typically going to be lower than rain garden soil moisture. So if you really don't know and just want a generalized list for those practices, you can choose those buttons. But if you want to play around with it and get more specific, you can choose the selections below. And the last, I think, slide of our presentation is the actual plant list. It's a pretty comprehensive list in terms of attributes. It tells you if plants are tolerant to deer browsing, rabbit browsing, if they're native to southern Wisconsin or just native to the Midwest in general. Also, it will give you flowering color and height and season. So a lot of information is packed into this tool. And the hope is that developers and residents in the district will adopt it and use it, and it will result in more successful green infrastructure designs. Lastly, we did work with Roy Diblick from Northwind Perennial Farms. You all may know Roy as one of the contributors to the Lurie Garden. He helped source the plants for that project and select individual species. He's an author and expert in the application of herbaceous plants in our Midwest area. And so he helped us choose which of these plants under the default conditions would be high performers, you know, real tried and true plants. And we use those to actually satisfy the district's initial request for templates. So at the end of this, if you really want to just get a template for each practice, we do provide that in this tool, and we provide it for beginners and for advanced people. And advanced just has a more diverse and complex planting arrangement. So this last slide is the one we're recommending for a bioswale for advanced users, and it has 2 different grasses and 3 forbs or perennials. So I hope the planting approach makes sense to you. I hope you're interested in the tool we created. It's available on MMSD's website at www.freshcoastguardians.com. We have been approached for developing this tool for other regions. This one, though, at Fresh Coast Guardians is specific to southern Wisconsin. So it's just good to bear that in mind if you're applying it in northern Illinois. A lot of the plants, most of the plants will still work, but we haven't sorted it for the specifics for native plants in terms of those that might be threatened and endangered in northern Illinois that aren't in southern Wisconsin, and vice versa. For example, I believe there's some echinacea pallida, I think is threatened in southern Wisconsin, but maybe not northern Illinois, or perhaps the other way around. So just caution on using that. But with that, I'd love taking any questions any might have. Thank you.
All right, great. Thank you, Jason. That was very good presentation. Very informative. We do have a couple questions that came in. Let's see. Mary Beth was asking or stating that DuPage County has many high clay soils. Any tips for encouraging infiltration in clay soil?
That's a great question. A lot of the native prairie plants have very deep roots. And so if you were using a rain garden application, native prairie plants would be a great for that type of application. They do tend to get into tighter clay soils much better than non-native plants. So that would be my first recommendation. There are a number of native prairie plants that have higher ornamental attributes if you're interested in using them in more of a garden style. So there's a wide variety now in the marketplace, native grasses and native forbs that are very ornamental and can be used in monocultures or more targeted sweeps of plants. Or you could reintroduce a truly diverse native plant system, native prairie plant community.
Okay, very good. Another question was, would a rock or mulch buffer between parking lot and plants helps reduce die-off from the high temperatures?
Yeah, that's a great suggestion. And yeah, there's a number of, you can really just substitute plants for some type of mulch adjacent to buildings, adjacent to parking lot curbs. It really, you just then have to maintain that mulch. So it's a trade-off, like how much of the plant community do you anticipate dying off and having to replace anyway? If you have a high amount of that, then yes, you might want to just replace it with a permanent mulch border. It's basically standard practice for me against buildings. For large commercial buildings, we usually keep plantings back anyway. So we often introduce, say, a 3-inch gravel layer for 2 feet next to a building foundation, just to keep plants from growing into the, right in that area. It's also standard practice for most green roof designs, where we have a different problem, which is wind coming up over the roof edge tends to desiccate plants and kill them within a 2 to 3 foot distance of the roof edge. So we also use a permanent gravel border there too. So that's a really good idea.
Okay, great. Another question that came in. Our detention area has 2 to 3 inches of standing water in the spring. What advice would you give for planting native plants under those conditions?
Well, it all depends on the duration of that 2 to 3 inches. So we, in our tool, have tracked the tolerance to certain flood inundations. And we relied on, there's a good resource, let me pull it up. This is my resource page. One of the best books that we've used is actually a 2-part book. It's on here. It's put out by the Minnesota, let's see. Oh, I'm sorry. It's under literature. I think it's Randy Schmidt, but Plants for Stormwater Design. There's volume 1 and volume 2 put out by the Minnesota Pollution Control Agency. Those are great resources for native plants. And it is Minnesota, but Northern Illinois is pretty close in terms of the types of plants. So there's a lot of overlap there. And they have tracked and recorded the tolerance for flood inundation for a lot of native plants. So that was our primary resource for that. That factor, which will lead you to the use of a lot more wetland plants. If you really do have 2 to 3 inches for more than a couple days, you pretty much have a wetland environment. And that resource will help you determine what plants you might use. Depending on the facility too, I mean, you could have a failure in the, we were just talking about plant selection today, but a lot of other things can go wrong in detention facilities and bioretention facilities. If it's holding 2 to 3 inches of water for more than a couple days, something else could be wrong. The soil sediment could have silted in and sealed off the surface, or there could be a clog in the drain pipes leading out from the system. So those would be other things to just double check on.
Okay, very good. Thank you. And one other question popped up here. Is there a link to the Green Infrastructure Plant Selection and Design tool?
I can make that available. I think they had changed the link, which is why I removed it from this website. You should be able to find it at freshcoastguardians.com. That's just MMSD's site for their sustainability initiatives. But I can follow up with an actual link to the tool.
Yeah, I think someone just kind of provided the that link in the
There
chat
it
box,
is.
actually.
Yeah, there it is.
Perfect. Okay. Well, Jason, I think that's all we have time for, but I'd like to thank you one more time for sharing your knowledge and experience with us. It was very interesting. I'd also like to thank all of our audience, for joining us this afternoon. We hope you have enjoyed and learned a few things from this webinar. Please remember that Mary Mitros will email everyone with a link to this presentation, a recording of the webinar, and of course that PDH certificate. Our next webinar is scheduled for May 12th. And at that time, we will be talking about 7 steps to tree survival in stormwater projects. So we hope to see you then. Thank you very much, everyone, and have a great day. Thanks, Jason.
Thank you so much. Bye, everybody.